This is a tutorial about the specification of the asset administration shell, part 1, the Metamodel, and it is about version 3.0. 3.0 was published in April 2023. So let's start. So you know perhaps about the concept of the asset administration shell, but it is not only a concept. This is really a specification that enables interoperability. The first version of this meta model was published in 2018. So this was just shown at the Hanover Fair with a complete history of platform industry 4.0. In the meantime, we do have 4 documents for the specification of the asset administration shell. Part 1 was split into 3 parts. Part 2, the API is still a separate part. So here you see the 4 parts, and this tutorial will be about the meta model part 1. And what I also want to mention, and this is a number you should remember, is IEC 63278, because this is the standard that will cover the asset administration shell, and IEC 63278 will the part 2 will deal about part 1 of this series. So for whom is this tutorial? I already in a way said you should have an idea, and perhaps you heard about it, and this is really a prerequisite. So if you do not have any idea about what digital twins are good for and how they are fitting into your domain, this is probably not the right starting point. You should know about the basic concept of the asset administration shell. You should also have basic knowledge in UML. So I will explain the most important concepts, and the main stakeholders for these tutorials are architects and developers. So if you want to know about the underlying information model of the asset administration shell, the meta model, or if you are a developer and want to start with your first implementation, or you want to upgrade and you already implemented, for example, version 2.0, then this tutorial is also a good starting point to learn about version 3.0. So if you belong to the group of people for whom this tutorial is probably not the right starting point, then I would recommend that you have a look at the administration shell reading guide, because there we have recommendations how to start for all kinds of stakeholders, for managers, for decision makers, but also for developers and architects. And this is the one for developers and architects, but also for security experts and so on, because security aspects will be part of part 4 and are also not part of this tutorial. Okay, then now it's getting technical. Or first, of course, the first thing you should do is to download the specification. I already did it, so here it's I downloaded it. It's part of, you can download it at the content hub of the Industrial Digital Twin Association, and I recommend you to look at the bookmarks here. You will see the structure of the document. So this is the first thing to do, okay. Then what is also equally or even more important for developers is to have a look at the specifications in the GitHub repository. Here I do have the GitHub repositories, because in this GitHub repositories you will find all the schematas. So here you find the releases, and you also find them here in the last in the master branch. We do have schema for XML, JSON and RDF, and you will also find an XMI format, that's the UML format. So if you also do have a tooling for UML, for example, it's best with Enterprise Architect, but it's a standardized format, XMI, you might also just want to import it into your tool, and then you can even have the complete model, meta model in your tooling, and it's easier to look up classes and so on. So then, what is also mainly, this is important for those of you who already know about version, the previous release candidates, or who implemented version 2.0. And there is an annex in the specification, and here you find all the changes with respect to 2.0, but also the changes with respect to the previous release candidate. So this is important. Some of you perhaps also already saw my tutorial on version 3.0 release candidate 2. So this will also be an update on this. In red, so only that you know, if you do not have any knowledge about either release candidate 2 of version 3.0 or release 2.0, then the red notes are not important for you, but for all of you who already implemented something, that these hints are probably very useful for you. Okay, so first, that's now a little bit boring. UML. Some modeling styles are perhaps a little specific for the asset administration shell, and also for the tooling that was used to do the UML models. It's in Annex E. So if you are not sure you understand the diagrams, just have a look at Annex E. So it's mainly the classical COMG rules, of course, of UML. And here, for example, generalization. These are all identical. So here, that's a typical way how to do it with this arrow. This is a shortcut. Here you see class 3 is inheriting from class 1. So this is the case if the class 1 is not part of the diagram. And this is also a way to show what was inherited by which class. So here it's redundant. So you see here that class 2 attribute was inherited from class 1. Shared aggregation is also a very important concept of UML. So here you see it. Class 2 is shared by class 1, but it has an existence independent of class 1. So it's not a composition. And this is really extremely important for us, because there is a special notation on this. And we do have a special type that is called reference. So if we do have a diagram like this, in reality, it means that we do have a reference type, and that this reference type is referencing an element of class 2. I will go into more detail about this referencing, but this is really one of the basic concepts, and you should understand it, how we realize shared aggregation in the asset administration shell. In previous versions, perhaps some remember, we used a notation where we had a star behind the attribute. Now in this version, we did not mix the styles and always did it in the way of A. Enumerations. Sometimes we are using inheritance for enumerations, but this is really only for logical reasons, to show how all these enumerations are related. In reality, such an enumeration is identical to this one. So an enumeration AB, an enumeration 1 has two values, A and B, and that's the same as this inheritance. This inheritance is not supported by most programming languages, so this is really only for logical relationships between enumerations. And then we do have, that's also in the Annex D, so how to read our tables for classes, for enumerations, and so on. And there you find all the details. I will not go into detail here, because I think it's also quite intuitive, probably, What is changed, there is no kind column anymore, and the way how to do a notation has changed a little bit, but in general, I think it's quite clear. So the model reference is probably something that is the most relevant, and as I just said, referencing is really a chapter in the specification you should have a closer look at, and we will also have a closer look at later in this tutorial. Yeah, and that's just an example, the example of a property class. Here you see the class that is inheriting from the class data element. It has 3 attributes. Here you see the 3 attributes. This is a type. We do see the cardinality and also an explanation. And in this example, you even see a constraint, an additional constraint, stating how value ID and value, in this case, in this example, are related. So this is a way the specification is built always a diagram and then the corresponding tables. Okay, that was just the notation and how we use UML and how we write it down. So now we are getting really to the meta model itself. And in a way, the goal of the complete tutorial is to read this diagram, and this is just, of course, an abstract or extract from the meta model, not the complete one. And so this is what it is all about. And for some of you who already saw this diagram from previous versions, so what is not there anymore, it was there in version 2.0, are views. There are no assets as separate class. Asset information is there, so this is still very important that you do have information about the asset administration shell is representing. And what is also different, and I already said it, part 4 will cover security, and that's why security classes are not contained any longer in part 1, and I will not explain them in this tutorial. Okay, so then let's start. Now, again, I start with what is common, and the complete specification is built on abstract classes in a way. So we are speaking about identifiables and classes or elements that do have semantics and so on. And these abstract classes are in the chapter common attributes. And this is why I start with those. So they are really important to understand the way the elements are used in the meta model. And here one hint, so don't wonder when classes are starting with HO or H1, 2, 3. This is just a tooling issue, and in most diagrams this can be hidden, but unfortunately not in the package view. Okay, then start with one of the really basic abstract classes. We are talking about referables and identifiables. And this is really, really important because both of them can be referenced. As I told you, references are a very important concept of the asset administration shell. The difference is that identifiables do really have a globally unique ID, a globally unique identifier, whereas referables are only unique within the context of an identifiable, and it might also be a deeper hierarchy, so a complete path to make it unique. They can be referenced, but they are not globally unique as such. Though they do have, typically they do have an ID short, and so this is the way a referable is typically referenced. Then what is also important is that identifiables do have administrative information, and this means versioning and also who created the element, so for example, who created the submodel. And also new is the template ID. We will learn about templates later. So if a submodel is derived from a submodel template, then a template ID is also specified here. Yeah, and here also some notes for experts. In previous versions, the ID had two attributes, was a complex type, the ID type and the ID. So this we changed, it's just an ID now, just a string. The ID short is optional, but this only is the case for identifiables and for elements within a list, because in a list the elements are numbered and not do not have an ID short. What is also new is a display name. You can add a display name, and as you see here, the category is deprecated and probably will be removed in the next one of the next versions. Yeah, creator and template ID, I already said, is also new. Oh. So then also important is the concept of qualifiable. A qualifiable means that an element may have one or several qualifiers. It does not need to have them. And what is a qualifier? And here, for example, you will find some standardized qualifiers from IEC CDD. It's, for example, like something like a life cycle qualifier. And life cycle is, for example, in planning, in build, in operating, and also some others. And we are distinguishing three kinds of qualifiers. A value qualifier, this means that the value itself is qualified. So for example, if you measure a temperature, the qualifier may say that whether it's measured or just estimated. So it changes over time. Then we do have a concept qualifier, and this, for example, is the life cycle qualifier. So you might have a bill of material as planned, or you might have a bill of material as built. So this might be this is a concept, an example for a concept qualifier. And then we do have template qualifier. This is something that is not part of the submodel itself, but is explaining how to build a submodel, for example, with respect to cardinality, multiplicity, and so on. We say it's still experimental because we just introduced them. Those stereotype experimental also means don't rely on it. Similar to deprecated, it might change in future releases or can be removed. Here, because so semantics, I have problems with my mouse here. So has semantics is also, of course, as we always say, semantics is key. So asset administration shell is for interoperability, and interoperability means you need to understand the data you are exchanging. Here on the right side you see a little example, the maximum rotation speed. Of course you don't know that it is the maximum rotation speed, only we humans know it because the name is now quite nice, so we know it. But if you only would see the value 2000, you wouldn't know it. It could be the year 2000 or 2000 steps or whatever. So what you need is a semantic ID, we call it. In this case, it's a semantic ID from eClass. And if you have a look at eClass and look it up, you will see, okay, it's the maximum rotation speed, it's integer, and it's a measured value. This is the unit of the measure, rotation in minutes. And there is also a definition. This is a definition in English, but you will also find definitions in other languages, German, French, Chinese, whatever you need. So this is an important thing for semantics, and this is the very, very important abstract class has semantics. And what is new is that we do not only have one semantic ID, we do now also have supplemental semantic IDs, because there are sometimes, for example, we will see it on the next slide perhaps when I discuss matching strategy, there might be reasons to have more than one semantic ID, but the semantic ID, this one is the main semantic ID. that is mainly used for matching algorithms. It is optional. In previous versions it was mandatory, so this is a discussion that is going on all the time. But I really can recommend semantics IDs are one of the really basic concept of the asset administration shell. Without semantics, data exchange does not make sense. So here we do have some matching strategies, because this is a question we got a lot. How exactly do two things match? With respect to semantics, when are two things semantically identical? And the easiest way, of course, is exact matching. And if the ID is identical, then for sure the two properties have the same semantics. I think this is really a very easy way to do it. But then you are probably discussing, what about versioning? So here, for example, we have two IRDIs, and one has version 2 and this has version 3. So are they now semantically identical or not? Of course, it always depends on the dictionary you are using, whether versioning means it is not backward compatible or whether it means it is backward compatible. So this might be some kind of intelligent matching where you ignore versioning because you know it doesn't matter for your application whether it's version 2, 3 or 4. Then another way of matching is to consider semantic mappings. And here in this example, we do have two different dictionaries. The right side is the dictionary E-class, and on the left side, we do have the dictionary IEC CDD. And so they do have different numbers, but they do have the same semantics. And if you do have such a semantic mapping list, then you can also use it as one kind of intelligent mapping. And another way of intelligent matching is, and this is more about ontologies perhaps, but also about classifications. Again, an example from E-class. And here we do have a drill for mineral material, and per hammer drill and percussion drill, at least according to E-class, so I don't have knowledge on this, are kinds of drill for mineral material and are both suitable for it. So if you are looking and for something for drilling mineral material, both of them might be a match for your application. So we are not saying that these matching strategies are complete, only to give you an example of what this means in practice. This is something new in version 3.0 to also have some extensions, the abstract class. An extension is meant for proprietary extensions. This is not for interoperability. This will not be standardized as part of a submodel template. So this is something you can add additional information. You can even add your own semantics and so on. You can even refer to elements within your asset administration shell and so on. But this is really for proprietary extensions only. And what we also do have is a concept for standardized way of, it's also some kind of extension, so to say. It is called data specification, and a data specification is standardized. So far we do have one standardized data specification. It's 3A, we call it. It's a series. Part 3 is all about standardized data specifications. Here it is about properties and values enumerations conform to IEC 61360. So this is not part of this tutorial, but this is one of the data specifications we are defining, in this case for concept descriptions. And then we do have the abstract class has kind. I already mentioned a lot submodels and submodel templates. And if you know the concept of the asset administration shell, you might have an idea what it is about, and that the template is guiding the creation of a submodel instance. Typically, if we say submodel, we mean a submodel instance. And this is exactly here the distinction. We have submodel templates and submodel instances. In previous versions, we also had template and instances for submodel elements, but now we only have it for the submodel itself. This means if the submodel is a template, then also all its elements are templates and interpreted as elements. And don't mix it up with asset kind, because yeah, it's also type and instance, and now we have a third value not applicable, but this is really about the asset and not about the submodel or the asset administration shell. It's about product types, it's about product instances. This is something completely different. A submodel instance can represent an asset type or a type asset, or it can represent an instant asset, a product instance. And here in the IDTA, there is a complete library of AAS submodel templates, and you also find them in GitHub with machine-readable versions of the submodel template. So this is about templates, and the easiest way to explain it, submodels do have values, submodel templates don't. They are only telling you how to build the submodel. Now, referencing. I already told you that referencing is really a very, yeah, it's a basic concept. It's not important for understanding the concept of the asset administration shell, but it's important for implementing the asset administration shell. And we do distinguish two kinds of references: external references and model references. And in the case, an external reference insofar has one key type, it's global reference. Model references are references that reference an element within a submodel of the same submodel, another submodel, a submodel from another asset administration shell. So anything from the Metamodel I'm just telling you about can be referenced. And here are all the referables, so only referables can be referenced, and this is a list of all referables. And we also have an attribute referred semantic ID. This means that this is the semantics of the element you are referring to. It's optional. If it's important for you that you are, for example, referencing a bill of materials submodel, then you should use this referred semantic ID. Yeah, and you also, if you already understood the reference concept, you should have a look at it again. It is changed a little bit, as you see, so we now have reference types. But in general, it's very similar to what it was before. Here are some examples for referencing, and in this case, this is also one message. There is a standardized way to put such a complex reference that is more like a path into a string, and here we see several. This is a grammar, and here are examples. For example, this is an external reference. The key type is global reference, and this is the value, in this case an E-class IRDI. The external ref or model ref is optional, so here in this case it's made very explicit that it's an external ref. And then here is an example of a model reference. Here this is a reference to the title of a document, and so first you have the key type submodel. It's within a submodel. It's within a submodel list of documents. And then you have a single document. In this case, it's the first document in the list, and lists start with 0. That's why it's 0. And then you address the title of this first document within this list in this submodel. This is how referencing is done with these passes. And here are some more model references, for example, concept description, and so on. So there is a complete chapter about this string serialization, and you will find many more examples also how to do referencing. So this was only the basic concepts, the abstract classes, and the way how we reference or we implement referencing in the meta model of the asset administration shell. Now we have a look at the asset administration shell itself, but now it's getting a little bit more easy, I would say, because we already saw it in the overview picture in asset administration shell, and this is now something that is probably very clear to you. An asset administration shell consists of one or several submodels. It can also be zero at the beginning when you don't yet have a submodel, but you already know that you want to create a digital twin for your asset. And the asset is described in this attribute called asset information. And it has several attributes. Some of them are new, like the asset type or the default thumbnail. And the asset type is also perhaps interesting for some of you, because the asset type says typically if you have an asset of an instance asset, you might want to know what it is, what is its type. And so both of them do have a global asset ID, though this asset type is a global asset ID of the type asset, if your asset is an instance asset. So this is the way how to describe the asset itself that is represented by the asset administration shell. Additionally, often you do not have the global asset ID, but for example, the serial number or some other information about your asset. This is called a specific asset IDs. These specific asset IDs typically are not unique, but they are used for discovery of asset administration shells in different contexts. Yeah, then the submodel itself. This is what applications are most interested in, and very easy. A submodel is consisting of submodel elements. And of course, it does have a semantics. It can be a submodel template or a submodel instance, has kind. It's identifiable in itself, it's qualifiable, and it might have data specifications, but so far we did not standardize any for them. It is also, you can also put extensions to it. This is inherited via the identifiable abstract class. Okay, so this is an overview. You will find it in chapter 537 of all the submodel elements we do have, and here you see the complete list in an alphabetic order, so annotated relationships, basic events, blobs, capability, data elements, entities, events, files, multi-language properties, operations, properties, ranges, reference element, relationship element, submodel element collection, and submodel element lists. Here you will see it in a UML diagram with all the attributes. I will not explain all of them. I think most of them are quite obvious what it is about, but some of them I will explain in more detail. And this is the difference between collections and lists, because this is also something that is new. It was before we only had collections. Now we are distinguishing between collections and lists. And the main difference is, here I have a very simple example in JSON format. Here, names of family members. Here, every member of the family has its own name. It has its own ID short, we would say, of the referable, name of mother, name of father, name of son, and so on. And in a list, you would just say, this is a family member, this is family member 1, 2, and 3. So all of them are submodel elements, and they also can have different semantics IDs. That's okay. But the way how it is treated and implemented is quite different. So here you have a fixed number, a maximum number of possible attributes. Here you have an, in a way, infinite number of elements within the list. Yeah, so here that's why you have a semantic ID list element. So here you have a semantics, and in this case, the semantic is family member. And if you would have an ontology, you would know that a mother and a father and so on are family members. And this is why the element might have a different semantic ID, but then we of course need some intelligent matching. So far we don't have it, so in the moment we assume that it has the same semantic ID, the one that is specified in this list. It's the same for the type of the elements. So typically in a list, all the elements in a list have the same type, whereas in a collection you could have completely different types of elements. You could have collections, operations, ranges, whatever you want. So this is important to understand. Another thing, a question we all often get: how exactly do we support composites, complex assets, and so on? And in very previous document, it was called Composite Industry 4.0 components. And the answer is the meta model itself does not support hierarchies of assets or hierarchies of asset administration shell or composites of asset administration shells. How this is done is via submodels. So we are talking about complex assets, composite assets. And so the asset might be complex and composite, but then you probably do have a submodel bill of materials. And in previous versions of the specifications, we even had an attribute for asset information where the bill of material was referenced, so that you know, oh, it's composite. Now we don't have it anymore. So, but if there is a bill of material, and we do support all kinds of bill of materials because we have a relationship element, and this relationship element may specify whatever relationship is important for you about the parts of the asset you want to describe. So also different elements of your asset you can describe with different submodels, with different relationships, with different semantics of these relationships. And this is the way we are doing this. So it is supported, but it is not part of the meta model, and this is not needed. Of course, we do have, you need to find the parts if the asset is composed of different parts, and all of these parts are assumed to have an asset ID similar to the composite asset itself. And this is where we do have the a predefined submodel element called entity, and this entity, as you see, do have a global asset ID or also specific asset IDs, and via these IDs you can find the corresponding asset administration shell if the asset does have an asset administration shell in itself. Some don't, and this is what we call co-managed entity, and this we also support. So a co-managed entity is really described within the composite asset, within the asset administration shell of the composite asset. But in very complex assets where all the parts do have their own asset administration shell, then we call it a self-managed entity. And again, this is then found via the global asset ID of the asset. Yeah, and now also, because this is also something that is confusing sometimes, people I explained data specifications as a very generic concept where you can add standardized attributes to some elements within the meta model without changing the meta model itself. So far we only have one for properties, for describing a concept for a property conforming to IEC 61360 standard. And in the schematas, we are using and implementing them in an embedded what we call embedded data specification, and this is how it's implemented. Though don't wonder, it's really here the embedded data specification. You have the reference, so every data specification has a unique ID. That's the data specification itself, and then it has some content, and the content is, for example, something like this with standardized attributes. And as I said before, there are special parts describing these data specifications. Okay, and then yeah, this was the meta model. And now, if you want to create your first digital twin, I always recommend to start with the AAS Package Explorer. You find it also in GitHub. And this is a very, very good way to learn about the meta model also. That's why I am recommending it. There are also many, many other reasons to recommend to use the AAS Package Explorer, but I think it's also a very good way to learn about the meta model of the asset administration shell. And I already said it before that in GitHub we also have different schemas. And we also have, but they are maintained by the OPC Foundation or the Automation ML Association. We have different serializations and formats to support the asset administration shell. And here, as I said before, you find them. There's also some chapters where you also find the links. But here again, you should have a look at the GitHub immediately. And here, for example, if you go to XML, you will find also the mapping rules. And this, of course, the mapping rules differ depending on the format. And here you find all, the information, how it was mapped, and also reasons why it was mapped like it was. Before, these mapping rules were part of the specifications, and even the schemas themselves were just copied into the annex. This is not done anymore, so this GitHub really is now part of the release, and this is for the developers the source where to look. Yeah, and open source support. There is also, of course, other support. There are many open source implementations, and we assume that very soon there will be also, they will update it, or there will be new tools or SDKs, whatever you need for asset administration shell version 3.0. So here in this repository I already showed you, but also here in this Eclipse top-level project Digital Twin, you also here, this is the status of April 2023, where you will find also SDKs and other open source support. Yeah, and and I assume there are, if you still do have questions, we also have, again, in GitHub, one repository called Questions and Answers. You can add your question to the issues and just create an issue. You can have a look at the questions and answers. So here, if we have a look for it, and perhaps some of your questions then will be answered. And if not, as I said, just raise an issue. So here you see questions that are often asked. So just become part of the community then. And then there is also a training from the University for Industry. That is also a very good starting point. There is also for awareness training, but also for developers. Yeah, and that's it. So let's go. And for the end, of course, I also recommend to really be, or your company to be, a member of the IDTA. Here just I went through this very, very fast. So in the meantime, we do have more than 100 members. And of course, we do have a lot of discussions. And if you want to drive and to yeah, to drive this standard together with us, and yeah, just be an active member of IDTA. So this is just whom you listen to. So my name is Birgit Boss. I'm with Bosch Connected Industry. I'm also one of the board members of the IDTA. I'm also the chair of the working stream that is doing these specifications, but I'm also active in other organizations like Catena X, and I'm also a PMC member of this digital twin top level project I just showed you. Yeah, so I hope that this tutorial was helpful for you and that you are now able to make your first implementation or do know how to start with your implementation. Thank you.